you go back to trig, all of these things start to make some sense. Now let's challenge another one. Okay. For all complex numbers z such that z, well, the modulus is 1, which make the problem simpler. Because z is 1 means that everything's on the unit circle. That's when things get easier. And this is a big thing, right? So then you'll be looking at how to maneuver this, because it's a modulus, right? So you got to make sure this modulus equals 1. Either you do it this way, like what we usually do, because he's showing a modulus, right? And then you can say, well, this has to be 2, because this will help us to make 2 complex numbers, right? We either do this. That's usually what we do. Well, the other one is the conjugate of it, right? Either do that, because at least you can start to do it. This is one way to do it, or you can do then you if you find the common denominator as z bar times z, right? So here's my z times z bar. That equals 1. And then we get z squared plus z bar. Well, that's z bar. Yeah, that's z bar, right? So this multiplied by z bar. Z bar squared over z times z bar. I equals 1. We know this one, right? We're familiar with that one. So, again, we can split this to we know what this one is. This equals that thing squared, right? And because this is 1, so that the denominator is gone. Right? So this simplifies it. So let's go this way. Okay. And let's say, well, z is not 0, right? If z is 0, there's no way that this is a 1. So z is not 0. If z is not 0, then we have a trig representation of this. Right? We can write it this way because it's not 0. And now you know what? R is 1. So that it's just simply cosine theta plus I sine theta. Right? It's a trig representation of it. So we can go with z squared. Well, you know how to calculate z squared. Cosine theta plus I sine theta. Let's do that first. So this squared, right, is cosine theta squared minus sine theta squared plus 2 times cosine theta sine theta, and put an I here. Right? So this is the expansion of a sum of a square of a sum. So this trig identity tells us that this is cosine 2 theta, and this one is sine 2 theta. Okay? So this is z squared. Well, on that side, we have z bar squared. As we know that z bar squared is just z squared bar, right? They're equal. So it means this is the conjugate of each other, right? This is the conjugate of each other. So if they're the conjugate of each other, then the imaginary part is gone, right? Yeah, because they're the conjugate of each other. Well, this plus that, this part is gone. So you're left with 2 times the real part. What's the real part? Real part is cosine 2 theta, right? So it becomes 2 times cosine 2 theta. This equals 1. Right? This equals 1. Which is cosine 2 theta equals 1 over 2. Absolute value here. So this is saying either cosine 2 theta equals 1/2 or cosine 2 theta equals negative 1/2. Right? So I'm not sure if you've learned this so far in your math class in school. This is still trig. Right? So when we know cosine 2 theta is 1/2 and we want to know what theta is, have you ever tried this problem? Aaron?
Nope.
No? Okay, so you haven't learned it yet.
Math in school is just like, we're practically doing coordinates right now.
Oh. Zypher? Do you know how to find the value of theta? If I know cosine 2 theta is 1/2.
I don't know, take like arc cosine or something.
Arc cosine. It could work. Yeah, it works. Yeah, you go with arc cosine 2 theta, right? It's 1/2, right? It's 1/2. Oh. Yeah. When it's positive, cosine value is positive. It's either in quadrant 1 or quadrant 4, right? It means that because we know arc cosine 1/2, this is pi over 3, right? Arc cosine 1/2 is pi over 3.
Yeah.
Right? Okay. That's pi over 3. So it means this could be in quadrant 4 as well. Right? Is it either? So one half equals that, because this will make it 1/2. This also make it 1/2, right? So it's pi over 3 or negative pi over 3. These two values will give us cosine value as 1/2. So then we have 2 theta either equals pi over 3 plus 2k pi, because there are infinite number of angles on the same location, or 2 theta equals negative pi over 3 plus 2k pi. Right, this is one case here. And the other case, when this is negative 2 1/2, we have 2 theta equals 2 pi over 3 plus 2k pi, or negative plus 2k pi. Then you just take values of k, right? So make k equals to something that, make sure the result is within 0 to 2 pi. So in that case, so if I take this divided by 2, I get theta equals pi over 6 plus k pi. And here we have theta equals negative pi over 6 plus k pi. In this case, theta equals pi over 3 plus k pi. Theta equals negative pi over 3 plus k pi, right? So if k is 0, I get theta equals pi over 6, and if k equals 1, I get this. I can't make it 2, because if it's 2, it's bigger than 2 pi. K can't be 0, when it's 0, it's less than 0. But I can make it 1, so when it's 1, you get 5 pi over 6. When it's 2, you get 11, right? And you can try here, theta equals pi over 3, when k equals 0, and k equals 1. It can't be 2, because 2 is more than 2 pi. It's k equals 1, k equals 2. So these are the 8 values, right? So when we write it, we can write it as cosine theta equals I sine theta, where theta equals to all these values, right? So there are 8 complex numbers that can fit into this equation here. All right. So these are the more complex problems that you need to know quite a bit about a trig. Right. So last time those questions are relatively easy. You don't have to explore different things, right? So this is like maybe a 1 unit to just talk about whenever you have cosine 2 theta or 3 theta equals to some value, and then you try to find the value of theta. That could be one topic in your trig lesson. Or so this is a combination of a lot of stuff, right? So that we have a solution for this problem. Okay. Okay, so it's time. I know this is hard, right? So Alexa, stop. But I should give you some hard ones, right? So you stretch a bit. Some problems like we did last time, they're relatively easy. You should also do those ones. Well, were those ones easy for you last time?
I think I figured something out in that.
Okay. Yeah. So then next time it'll be easier. Okay. Next time it's easier. This time is actually much harder. This could be the hardest for this lesson. Right. It can be harder. I wouldn't give it ones. This is as hard as it can be. I try to make it not harder than this one. All right.
Okay.
Any question? Questions?
No.
No? Maybe there are too many questions. Oh, well, you should go or if there's anything, right? I mentioned for trig, maybe you want to review it. You want to do some exercises. You get more familiar with those trig identities. So I talk about a lot of trig identities, which means there are chances for you to use those identities when you learn them, right?